Now we're gonna do number 11 through 15. Okay, so in this case, let's read 11. Customer at the bank are charged fee when they are exchanged US dollar for foreign currency. The function f of x equals 78.5 minus 392.5 can be used to determine the number of Japanese yen a customer receives in exchange for x dollar, where x greater than 5. Which table shows this relationship? So which table shows this relation? So this is very simple question. You have tables, so guess what? If you can graph the equation in the calculator and get your table and match. So how to do that? You go to new document, you press no, you go to add graph, always you put your equation, then you graph it first, then you do Control T. So you put your equation as you see it, 78.5 x minus 392.5. Now you're gonna graph it, then Control T for table. Now let's see at 50. So it's simple. You go to x, and I want to see when x equals 50. Which table I'm gonna eliminate? 3,500. Okay, so for the first one, this is good. So I'm gonna eliminate this one because I don't have 4,300. Let's see 65, or you know what? I see 45. Let's see 45. 45, 3,140. 45. It's not this one. Now let's see 65. Kind of I'm using the elimination and check which one match. So for 65, 4,710, which it's not this one. So it's not D, it's not A, it's not B. Of course, it is C. And you can just check 85. For 85, we should have 6,200. There. So the answer is C. Easy question. Now, a rectangular prism has a width of x inches and the length of x squared y inches and the height of y squared inches. Which expression represents the volume in cubic inches of this rectangular prism? So I'm going to draw a rectangular prism. You know, it looks like something like this. So it's 3D shape. So imagine you have 3D shape. And something we should know, the volume always of rectangular prism, its length time height, length time width time height. So let me make a nice one. So our 3D representation will be nice. Okay, so this is your length, width, and height. The only thing we have to know the volume, its length, time width, time height. In some cases, the volume, its area, time height. And of course, we know the area of the base, its length, time width. So you see the area, its length, time width. But let's keep it simple, its length, time width, time height. In this case, what is your width? The width, it's x. Now, what is the height? The height, it's y squared. And the length, it's x squared y. So what's the volume? Again, the volume, it's length, which x squared y, time x time y squared. Now let's combine. Let's apply the law of exponent. When we multiply the same base with different exponent, what we do to our exponent, we add. So the first one would be x cubed. How about y times y squared? It would be y cubed. So this is the answer you're seeking. In this case, it can be J. Easy and simple question. So they said the graph of line T is shown in the grid. So guess what? This is line T. They call it line T. That's the name of this line, T. Line W, it's steeper than line T. So line W, it's another line. So we have two lines. So what we know about line W, it's steeper than line T and has a y-intercept that's below the y-intercept of line T. Which function could be line W? First thing, what's the equation of line T? Let's find the equation of line T. So the equation of line T. So that's why T means the equation of line T. What is the slope here? You go 2 down and 4, or you go 1 and 2. So the slope is -1/2 x. The y-intercept there, 2 plus 2. So your B is +2 and the slope is -/2. Now, line W. What's the equation of line W? They told you it's steeper and the y-intercept it's below. So the y-intercept has to be less than 2. So in this case, you can cross B and C because the y-intercept has to be below 2, less than 2. So either A or B. So we agree we saw -1, so it could be -1. But what means steeper? Means it has to be above. Above. Steeper means the T has to be above. Above. In this case, if this is -1/2, the new slope should be more than -1/2. So which number is more -1/2? -2/3 or -1/4? If you cannot see it, this is what you do. So if you go 2 down and 3, guess what? Nope, this is not more steeper. It's not going to be -2/3. Now let's see. If you go 1 down and then 4, you see how your line T would be in the top. So it would be steeper. So in this case, the right equation is going to be D. Senior employee work 16 hours, earn 39.5 more than a junior employee who worked 18 hours. The senior employee earned $14 per hour. What's the hourly pay in dollar and cent for the junior employee? So in this case, this is a lot of reading. So usually what I do, I ask my student to have a visual picture. What means visual picture? Means I want you to see two people. How about the first one? Represent the senior employee. You see, nice mustache. How about nice head? Like cowboy head. What do we know about the senior? And then another junior. Kind of baseball head, younger man. So in this case, let's see everything. The senior employee work only 16 hours and earn $39 more, 39.5 more than this young man that he work 18 hours. So technically, when this man work 18 hours and this guy work only 16 hours, this man, he make $39.50 more than this gentleman. And you see, he work less hour, make more money. What else do we know about the senior employee? He earned $14 per what? Hour. So we're gonna do basic math. If he does 16 hours at $14 per hour, how much money he make total? Let's see. So you're gonna use your calculator. You're gonna calculate. You do 16 times 14. That's $224. The only thing we know, how much total he will make. If the senior make 224, how much the junior will make? Of course, he will make $39 less. So he will make 224 minus 39.5. This is how much he make. So let's do the math. So that's minus 39. This is just basic math, 0.5. He make 184. So imagine if he make $184.50 in 18 hours. So what's his rate per hour? So what you do the total, divide the 18. So 184.5 divide 18. That will give you how much he make per hour. He make $10.25 per hour. So this is the answer. He's happy now because we know how much money he make. Now let's go to number 15. In 3 different workout, a runner burned 300 calories in 30 minutes, 350 calories in 35 minutes, and 200 calories in 20 minutes. Based on the data, which statement is true about the number of calories burned is a function of the number of minutes in the runner workout. So let me do a table. So this is X and Y. Always I'm using X and Y, but in this case, let's see, this is the minute and this is the calorie. This guy, he burned. So in 30 minutes, he burned 300 calories. Now in 35 minutes, he burned 350. In 20 minutes, he burned 200. Let me put this on the top so we have organized data. Okay, so this is the table. Now, the number of minutes the runner work out, it's depend in the quantity. So usually, let's talk about dependent, independent. What do we know about X? We're gonna use this as a review. X, it's your input. X, it's your independent. X, it's your domain. Now, what do we know about the Y? Output, dependent, and range. And the main thing we know that Y depend on X always. So basically, the time it's your X, the calorie it's your Y. So we know that the calorie depend on time for sure. So the first statement, the number of minutes depend in the quantity, I don't think so. It's false statement. The number of workout the runner complete, it's the depend quality. So it said the number of workout the runner complete it's the depend of the quantity. Nope. Look, the number of calorie burn, it's the depend quantity. The number of calories burned, it's the depend quantity. Yes, this statement is true, but let's see the next one. The number of step the runner take is depend. What's the step has to do? We have only 2 variables. We have the burning calories. That's how many calories he work out through his workout, and the minute. So the minute would be your independent. The calorie burn would be your dependent. So the only statement makes sense. It's C. I hope you enjoyed this video, and then the next one will be 16 to 20.